between 0 and 450. I think we had enough of this. Okay, I have a chat. It could be a little bit more than 100. I can completely agree. Yes, I agree with both. Yes. I did not zoom in. From the distance I'm at between myself and computer, my laptop, I estimated 100, but you are correct. It could be a little bit higher. I completely agree if we zoom in. Okay. So what 10-year age interval sees the greatest increase? The steepest increase. So obviously the function here has a peak, right? Where is it? It appears to be roughly around the age of 80, highest. So in order to find the increase, where's the fastest increase, just imagine we are drawing tangents. So here the tangent is like this, not too steep, but not very steep. At this point, the tangent is like this, very steep, and not as steep. The tangent is not as steep, and here the tangent has a slope 0. So here the tangent is something like this. Yeah, here is like this. Okay, but here is quite steep, the steepest it can be on this graph. And then here a little bit softer, here a little bit softer, not as acute. Here is 0, right? For 100,000, right? There is no increase here. And then it starts decreasing, negative slope. Okay, so I'm estimating somewhere between 50 and 60. Between the ages of 50 and 60 is the highest increase. The rate of increase is the highest. Again, here's like this, here's like this, but here is the highest, and then it mellows. The steepness decreases, and here is 0. So I'm estimating between 50 and 60. You can say 45 to 65, I would agree, but it appears to me that here is the highest increase. That's the most dangerous time. Okay, moving on, I would like to continue with the next section, which is 6.4. We talked about it, and I don't think we have any secrets. So allow me to stop sharing and just give you, this was page 5. Okay, so R.4, lines. So we know the slope given 2 points. We discussed this, y2 minus y1 over x2 minus x1. And this is the slope given 2 points. Then we have y equals mx plus b, which we discussed. Remind me if we didn't, or if you want any explanation. And then y minus y1 equals the slope times x minus x1. I'm combining stuff here. I talk in x minus x1. Sorry about that. Okay. Then we should talk about vertical and horizontal lines. What is the slope of a vertical line? Can anyone give us the slope of a vertical line? The slope.
Y equals mx plus b, right?
The slope of a vertical line.
X equals 4.
Undefined. The slope of a vertical line is undefined. Can anyone give us the slope of a horizontal line?
Undefined.
0.
Very good. You cannot walk on this. If you want to keep it, remember it like that. The easiest thing to walk on is the horizontal line. What about this? What type of slope? Not the number. Well, what type of slope is this? And what type of slope is this?
Linear.
Positive. And what type of slope is this?
Negative.
That's it. So please remember, vertical lines do not have slope. The slope is undefined. Horizontal lines have the nicest slope possible. When you go up the hill, that's a positive slope. When you come back downhill, it's a negative slope. So let's share. Let's share, and we are on page 44. Stop me if you have questions, please, anytime, please, please. Okay, so let's choose two ordered pairs and determine the slope and the equation of the line, and then move on to some word problems with equations of the line. So we're going to choose from here. This is all from your beginning algebra. Okay, so would you like to choose two ordered pairs, or I will?
You can.
Okay, if you allow me, thank you so much. I am going to choose 34. So for 34, oh, this is not a good color. For 34, we have negative 11, comma 2, and 1, comma 4. So the question here is find the equation of the line passing through these points. So obviously I have to use this equation because we know that this point is 0, comma a number. I do not have 0, comma a number. If I don't have 0, comma a number, I will not be using this. If I have 0, comma a number, I have to use the point slope form. With any of the points, it doesn't matter. So I'm going to write it for myself here. Y minus y1 equals the slope times x minus x1. And let's say I choose 1, comma 4. So y1 will be replaced by 4, x1 will be replaced by 1, but I need to determine this. Can anyone tell us how to determine the slope? We did this before with the difference quotient. We used that formula several times already. So the easiest thing to do is label, first of all, x1, y1, x2, y2.
Negative. Sorry.
4.
At the bottom, negative 11 minus 1.
So y2 minus y1, because I already labeled them, but you're correct. You don't have to change anything. So y2 minus y1, 4 minus 2, 1 minus negative 11. 1 minus negative 11. The top is 2. The denominator is 12. Do not attempt to simplify. You can simplify now because simplifying factors. 2 divided by 2 is 1. 12 divided by 2 is 6. So I have my number that I was missing, which is the slope. I have to solve for y. So I copy y minus 4 equals 1/6 x minus 1. So 1/6 times x, 1/6 times negative 1. And remember, when we move terms from one side to the other, we only change their sign. I need the least common denominator, as we did a few minutes ago. Don't write any symbol just yet. Just give me the least common denominator.
6.
Of course. So I have a negative 1 at the top, and this one is over 1, so it needs a 6. 6 times 4. So in that case, remember you have to put a plus in here, because I consider this in parentheses. You can twist this around, and then maybe it's easier to see it, and then you get the same thing, and it's 24 minus 1. 24 minus 1 or negative 1 plus 24, same thing. So then y equals 16x plus 23 over 6. What does this represent? It's the equation of the line passing through these points. The only equation. Now, will you get a different equation if you use negative 11 and 2? I used 1, 4. What if you use negative 11 comma 2 instead of 1 comma 4? Will you get a different line? No, of course not, because this is 0.1 and this is 0.2. I use 0.2, but if you use 0.1 with a slope of 1/6, it doesn't matter. It's like you're going up and I'm going down, right? Or vice versa. The steepness of the line will not matter, will not change. If we go up a hill or come back downhill, the steepness of the hill will not change. So it doesn't matter which line, which point you use. Why? Because we use both points to determine the slope. So it doesn't matter which one we use. Any questions on this problem for me? Anything?
No.
Is
Thank
there
you.
ever a point where it would matter though?
No. No,
Okay.
because we use both to determine the slope.
Okay.
So once I establish the slope, going uphill or coming downhill, the steepness will not change. Thank you for your question. Moving on. Okay, so now I would like to look at a word problem to identify, I don't know, profit and loss. I'd like to talk about that. Because we want to talk about cost, revenue, and profit. So let me explain before we look at problem 61. Okay, so let's talk about cost analysis. Cost, profit, revenue analysis. Okay, so the cost function, cost function has two components in general, right? It has the variable plus fixed. Fixed is like rent for the building, electricity, and so on and so forth. Just for the offices, if it's production, it may be included in the variable. And variable is raw material, it could be labor, and so on and so forth, depending on the number of units we manufacture. Okay, so this depends, variable depends on X. This one is fixed. It's just a number. Good. We are selling whatever we are producing. We are producing some, I don't know, what do you want to produce? Computers. So we produce computers and we sell them. And this is revenue. Money coming in, R of X. And at the end of the day, we are interested in profit. The profit, P of X, and the profit always equals money coming in minus money going out. Always. Revenue minus cost. Both minus. Minus the variable and minus the fixed. There is something called break-even point. Break-even point. When the revenue equals the cost, we are not making any money. Or when the profit is 0. They both mean the same thing. If these are equal, of course this is 0. If this is 0, of course these are equal. So the break-even point is X comma revenue of that X. Yes, any questions? Go ahead. So if I say that X equals 1,000 for the break-even point for the profit to be 0, then this number, this ordered pair will be 1,000, and this number is the revenue the revenue of 1,000. And this is the break-even point. Break-even point. With that information, I think we are ready to look at this problem. Where is it? Okay, so profit and loss analysis. So Jamal decides to mow lawns to earn money. The initial cost of his electric lawnmower. This is the fixed cost. He hasn't produced anything yet. So this is his initial cost. 250. So this will be the fixed. So 61 on page 45. So fixed. I'm just taking notes. Fixed 250. Okay. Electricity and maintenance costs are $4 per lawn. So variable cost, $4 per lawn. Formulate a function C of X for the total cost of mowing X lawns. So can anyone give us a function C of X?
It's just 4x minus 250.
Brilliant. Plus. This is the total cost. 4 per lawn plus his initial cost, fixed cost for the lawnmower. Perfect. Part B. He determines that the total profit function for the lawn mowing business is given by P of X equals 16x minus 250. Find the function for the total revenue from mowing X lawns. How much does Jamal charge per lawn? Okay. So we have the cost. We have the profit. What is the relationship between cost, profit, and revenue? So because we are asked to find the revenue. Find, so this is part A and this is part B. Find revenue. Function first. So what is the relationship?